Good morning and welcome back to the Wireshark Foundation class. In this module we will talk about timestamps and time values. Before we begin, just a quick reminder from what we learned about yesterday. When we use Wireshark, one of the key things we're using Wireshark to do is to analyze captured data that we capture specifically from strategic points on the network so that we can analyze, assess it, review what's captured, and try to figure out isolation down to root cause of a problem. One of the key things that we can do when doing this is to do relative time and review the value of time from when you, let's say, open a web browser to a site or an application, or you're FTPing some traffic, or you're trying to figure out why DNS queries might be slow. Any of these things can be captured with Wireshark. And when you do that, you're able to look at, for example, how long it took for something to get from a source to a destination. So in this module, what we will do is we will learn about how you can strategically change things within Wireshark, take a look at settings, and figure out how long it takes for something to get from a source to a destination. So essentially, what is a timestamp? When you open up Wireshark and you begin a capture, each packet is marked with the time that you're capturing. Now, this is not a time that's kept within Wireshark. It's actually using your system's time to make that timestamp. So what's important to understand is that if the time is off on your computer, for example, your capture data is not going to be accurate. So one of the things that you probably would like to do is check and make sure that the time on your system is correct. And one of the best ways to do this is to use NTP and configure your system with a solid time source. And when you do that, you will at least know that what Wireshark is capturing and timestamping is accurate. That being said, timestamps are used to mark the capturing of your packets, and you can convert to different time formats, which we'll do in this module. We'll take a look at the difference between certain settings that you can change and why you would use one over the other as an example. So why are we actually doing this? You are able to see the delta between packet capture. So if you, let's say, were to open up a web browser and try to access a website, you can see from when you start to when you finish and every activity in between how long it takes to do certain things. A good example would be if you were accessing a website and you were seeing GET requests, or you were doing posts and you were seeing a long period of time to complete a function. So what does that actually mean? That means that, as we learned yesterday in the other modules, you could potentially be facing quite a few different things. You can have latency on your network. There could be I/O problems on the web server. The client could have lack of memory to be able to handle the requests. There's so many different things that can be a problem within that source to destination round trip time and cause contention and or problems all the way from the client to the server. So just remember that you put on your detective hat and you have to look at all the things in between, as well as the client and the server. You want to make sure that you consider that the server could be N-tier. There could be multiple layers to that server, especially with today's web server technology. Usually it's a front-end web server. It's N-tier technology. There's generally 2 to 3 tiers. Sometimes it's split out into a middleware tier where you have application-specific functions taking place. And most websites, if they're complex enough and they're taking orders or storing information, have a database tier, and that could also be what's hanging things up. So just remember, It's not just the simple, it can get into the complex. So when you open up Wireshark, and we'll take a look at this now, you can see you can adjust the time display format. We're going to get into what each of these values means, but you can change the time display format. You can adjust it to seconds since time beginning of the capture, seconds since previous capture packet, seconds since previous displayed packets, and each one of those things is going to show you something different. So as an example, we'll open up Wireshark and we'll take a look. One of the things that we did here was we did a simple capture, and what I decided to do here is I just ran a basic capture. I accessed the website and I wanted to see the differences between, from my client to the destination, basic time values here where how long it took me to do a simple request of a web page. So as we were talking about before, there's different ways that you can adjust this, and if you go into the view, time display format, it originally was seconds since time, and then I wanted to change it to seconds since previous captured packet. Now what this allows me to do is to look at each one of these. I also looked at the stream, but I wanted to see specifically how long it was in between each function here in the capture. So essentially, that's one of the things that we want to do when we're capturing data. We want to make sure that we are adjusting time to how we want to see it. And what does that really mean? So absolute time, the time of day when the packet is captured. Essentially, one of the things that we want to do is we want to make sure that we pick the correct function, and we want to pick the correct value for what it is that we want to see, and they're pretty self-explanatory. So if I want to see something since the previous captured packet, it's going to look at the timestamp from the packet and then the very next one after that and show me the difference or the delta. And essentially, if I'm looking at each packet and each packet's performing a function, that will tell me how long it took to do each one of these functions. There's different ways that we can do this. It's automatic setting, or we can change into specific settings. With specific settings, we just want to make sure that we understand what we want to look for, and we can adjust those as we see fit. So let's go back to our capture. And here we'll do a simple capture. I'm going to start, and what we want to do is we want to go to our website. I'm going to show you a different tool here too, so we can look at a couple of different things here. But we will go to and when we pull up the website, as we can see, there's a couple of different things going on here. These are a lot of GET requests. And then we're going to stop our capture. And then we're going to look at specifically what we just did. So in here, we want to adjust the time display format to previously displayed. And we can see from each function how long it took to do each action on pulling the website. So one of the things that we want to remember is when we're doing these types of captures, what are we looking for? Are we going to check the delta? When you need to find latency in your network, you would use this type of time stamping. You can check for application response time. That's what we just did. We wanted to look at a website and see how fast it responded to our requests. We want to see if there's any errors in there, like 400 errors. To do this, we may want to put Wireshark on both sides of the capture. This is a very simple capture, but if we were doing something where we were looking at an end tier and we wanted to see a response on the database from the web tier, we may want to put a capture in between that. Otherwise, we will not see specifically the latency from one tier to the other. And we might have to filter the data on both hosts as we just did. We want to just see the HTTP traffic so we can limit what we see in the capture and not cause any confusion. And essentially, we're going to do this type of filtering just to see specifically how long it took to travel from source to destination in milliseconds. We can refine that, but essentially we want to see from source to destination how long it took to pull up a web page and how quickly it responded. Question about time. When you capture it, it is generally in milliseconds. You can bring it down to nanoseconds. One of the common things is not all capture files will be able to show this format. So when you're capturing data and you're sending it from place to place and you're sharing it, if somebody opens it up in a different type of packet analyzer, they may not be able to specifically read everything that you're sending them. So just be aware of that. Another concern is time zones. If it does consider time zones, so if you're sending it around, it will be something that they can read. Just be aware that if you're capturing something in a different time zone, to make sure that you understand it is from a different time zone so that you can read it and readjust it manually for yourself when you're troubleshooting with it. Okay, I was looking in the chat forum and there was a couple of questions that were asked. Let me just review. Okay, so back with the timestamps. So the question was, when you're doing this stuff, can you troubleshoot the entire transaction? Yes. When we get more into the flow graph, we can see the TCP handshake and how all that stuff works, and we'll be able to look at the timing in between that. But just as a general rule of thumb, if you pull up your Wireshark capture and you look at it as we did before, you can see in the left-hand side here of the window the time column, and you could see as you're doing each piece of the transaction. Here's a get, so obviously it's doing a request, and you can see when it goes through and posts, you can check to see how long it's taking. And generally anything over, let's say 40 or 50 milliseconds to pull something is probably not very good, depending on your connection. That was also another consideration. So one of the other tools that we were looking at before we closed out the session was, and I'll pull this up now, was other tools that you can use to validate specifically what is being done and what pages are being done. So there's tools out there that will allow you to pull down the entire cascading style sheet. There's things that will allow you to accelerate your service so you're not pulling down a ton of little packets. There's things that can be done to accelerate this, to reduce the amount of gets. So there's things that can be done to increase the performance here, but just in Wireshark, the realm of Wireshark, if you wanted to look at the actual data and check out and see what's happening here, you can validate from one step to the next exactly how long it's taking with timestamps. So it's important to understand timestamps. It's something that will help you when you're troubleshooting, because as an example, let's say you're looking at a transaction from a client to a server. One of the things that you could do is run a Wireshark capture at the client like we did here. If you have access, you can run one at the server and you can do a compare and take a look to see exactly what's going on within a specific set of time, so that you can see where the hang-up might be or where the performance hit may be. We were talking again about that performance hit. One of the key things that we were discussing and we were talking about, or at least I posted in the forum, was that I/O is a big thing. So if let's say you have a disk drive on the local server and the read-write times are poor, that will potentially show as slow performance when you're accessing a website. If the system doesn't have enough memory, if the NIC card is having an issue. Let's say it's not on a gig and it's on a fast Ethernet, and you see a lot of problems where it's actually buffering that traffic. There's a lot of things that you would look at to see if specifically if you had a performance issue outside. But this, in Wireshark, this example is one of those things where you may be able to get an understanding of where you need to look. So as we had mentioned before, if you see long periods of time or you see tons of GET requests, it might be something where it's just not able to provide you the page in time, or it's sending way too much traffic and you're not getting it back in time. So those are some of the things that you could check, not only capturing it in Wireshark and giving you a clue as to where to look, but specifically, do you have a problem on the client? Do you have a problem on the server? Do you have a problem in between on the network?